eyeball that seems individuals in a second. But I want to interrupt you with this question. So you mentioned that there can be a misalignment of the eyes. I've seen many people's babies where there is one eyeball that seems to be kind of drifting around, and then it might correct, but sometimes they'll have we don't want to get technical here for our listeners, we'll keep it general, but either convergent eyes or one eye converging, cross eyes, or wall-eyed, again, using that non-technical language here. And my understanding is that the brain is taking that information in and is very plastic. It's changing at these early stages of development, and that it's fairly critical to get that stuff corrected early on, because if you wait too long, the brain can essentially become blind to the brain cannot learn to handle the proper alignment. So in other words, if a kid has crossed eyes, and they're not corrected until their 20s, it's possible that they will never recover normal vision. Whereas if you align the eyes properly early in development, they can indeed recover vision. How early can and should one consider getting those eye realignments done?
Yeah, pretty much right on. What they'll do is if they detect any eye misalignment, and sometimes parents are good at noticing that, and sometimes you take a picture and one eye got the red eye reflex and the other one didn't, and sometimes people notice that their kids' eyes are sort of turning in. It seems like too much. Sometimes there's what's called pseudostrabismus, which is where actually, depending on your anatomy, if you have a little extra skin sort of on the inside corners of your eyes, it makes your eyes look turned in when actually they're straight. But if your eyes are actually turned in, or slightly less common in children, more common in adults, misalignment turned out, it's really important to correct that early. And the reason is, as you were saying, the brain starts ignoring it. It fails to fully develop the strong connections for the data coming in from one of those two eyes into the brain. And if you pass certain sort of thresholds during development, during childhood, without correcting that connectivity, getting those two eyes to work together properly, you can permanently lose that. And so we used to use very sort of, gross numbers, like it's fully correctable if you can intervene before age 3. It's partly correctable if you can intervene before age 6. You got a chance before age 9. But it turns out in follow-on studies that even kids into their young teens have a shot at correcting that eye-brain connection, that amblyopia, that loss of vision that can occur during early development. So even if you're only, unfortunately detecting that later on in childhood or even sort of the tween years or early teen years, it's still worth a try to really push to retrain the weaker eye and then also realign the muscles so that they can work together to keep the eyes focused. I'll tell you, it's interesting, and there's a lot more to learn about brain plasticity and probably a lot of really cool new therapies yet to discover that could reopen what's called critical period plasticity, this plasticity that we have during development that kind of goes away as we age. And that critical period plasticity, as you know, has been the best studied actually in the visual system. And the idea that we could reopen that is really fantastic. But for different parts of that eye-brain connection, there's different periods for critical period plasticity. For example, even if you get the amblyopic eye to see well again, and then you realign the eyes and now they're working together,